Hello everybody, today an example of pile groups is selected to illustrate some of the essential features of ELPLA for analyzing pile groups. As shown in the figure, a pile cap on 24 vertical piles is considered all piles are equal in diameter and length, where pile diameter is 0.5 meter while pile length is 10 meter. Spacing between piles is 1.6 meter. It's required to analyze the pile cap as rigid freestanding raft due to a vertical load of 8,000 kN acting on the pile cap with eccentricities EX 1.4 meter and EY 1.8 meter. The subsoil under the raft consists of a layer of silt which is 30 meters thick. The raft lies directly on the ground surface and there is no effect of water table on the raft, and the soil is supposed to have the following parameters: modulus of elasticity for loading, which is equal to 10,000 kN per meter square, and the modulus of elasticity for reloading, which is equal to 10,000 kN per meter square, and Poisson ratio, which is 0.3. So let's start using ELPLA. From File menu, choose New Project. The calculation method wizard appears. This wizard will guide you through the steps required to create the project. The first form of the wizard is the analysis type. So we have to define the analysis type of the problem. As the problem is pile groups, so choose analysis of combined pile draft. Click Next. The calculation method form appears with 9 different calculation methods. So choose rigid freestanding raft with layered soil model for the subsoil model. The system symmetry form appears. Choose unsymmetrical form. The last form of the wizard assistant is options list. For this one, ELPLA displays some of the available options corresponding to the used numerical model, which differ from model to another. For this example, there isn't any requested choices, then click Save button. Enter the file name. To identify the project, from Data tab, choose Project Identification. Enter the title of the project, let's say Analysis of Pile Groups. Here we have the date and the project name. To define the FENet, choose FENet data from the Data tab. The FENet generation wizard appears. This wizard will guide you through the steps required to generate a FENet. The first form of the wizard is the slab type, which contains a group of templates of different shapes of nets. These net templates are used to generate standard nets that have regular shapes. But for the given problem, the foundation has an irregular shape. In pile group problems, it is not required to generate a FENet for the entire dimension of the raft. Only a net containing pile locations is enough. ELPLA has different options to define the FENet. One of them is generating a mesh for the entire area firstly, then removing the unnecessary nodes to get the foundation shape. For the given problem, we have a rectangular raft of 6.4 meter in length and 8 meter nodes. So choose rectangular slab with 6.4 in length and 8 meter in width. Click next. The following generation type form appears. ELPLA can deal with different types of generations with triangle and or rectangular elements. Choose the first type of rectangular elements. Here is a grid definition form appears. We have to define the grid in both x and y directions with number of grid intervals and the grid interval in meter. As the spacing between piles is constant and is equal to 1.6 meter in both directions, so the grid interval will be 1.6. So we will have 4 grid intervals in x direction and 5 grid intervals in y direction. The grid interval will be 1.6, it's constant grid interval in both x and y direction, with 4 grid intervals in x, 5 grid intervals in y. Click finish. ELPLA will generate FENet for rectangular area of 6.4 meter in length and 8 meter in width with square elements of 1.6 meter in each side. Click save. To select the unnecessary nodes that are required to be removed from Edit FENet, choose Select Nodes, then choose the unnecessary nodes, then click Delete. Here we have the final shape of the raft. Click save and close the FENet window. To define the piles, choose Piles from Data tab. The following window appears. For the given problem, we have a group of piles which have the same diameter, length, and material properties, so we can't find them as a group. From in table menu, choose Pile Groups. Here we have a group of pile diameter 0.5 and pile length 10 meter. Description of our pile group will be P1, so click OK. To define the material properties of the group, choose Pile Material. Type 0 in the unit weight of pile concrete edit box to neglect the pile weight. Modulus of elasticity of pile will be the same, so it's okay. To select the nodes where piles are located, from graphical menu, choose Select Nodes. We have 24 piles, so we have 24 nodes where piles are located. After that, choose Add Piles from graphical menu. Finding Pile Groups edit box appear. choose pile group number 1. We don't have any other, so click OK. To edit each pile individually, you can choose pile locations and groups from in table menu. Here we have a list of 24 piles. You can edit the coordinates, pile label, and the group to which the pile belongs for each pile. Or you can choose edit pile from graphical menu and double click on the pile you have to edit. By the same way, you have to edit the coordinates, pile label, and the group to which the pile belongs. Click OK, click Save, and close Files window. To define the soil properties, choose Soil Properties from the Data tab. The following window appears with the default pouring log. In ELPLA, the pouring log can be defined or modified graphically, which makes the definition of the pouring log very easy. By double-clicking the left mouse button on a specified screen position, the user can define or modify the soil data and input parameters graphically. To edit the geotechnical data of the soil layer, double-click on the data. The corresponding dialog box appears, allowing you to modify the data. For the given problem, the modulus of elasticity for loading and reloading are the same, of 10,000 kN per meter square. The values are the same because the effect of reloading on the soil isn't required. The angle of internal friction and the cohesion of the soil aren't required because the selected type of analysis is linear analysis, so the user can let the default values of the angle of internal friction and the cohesion of the soil. Click OK and save. To define the type of the soil, double-click on the soil symbol of the soil layer. The corresponding dialog box appears, allowing you to modify the soil symbols of that layer. Choose Silt as main soil type. Click OK. The color of the silt and the short text U according to the German specification code automatically created. To modify the depth of the layer, double-click on the layer depth. The corresponding edit box appears, allowing you to modify the depth. Type 30 in the layer depth under the ground surface edit box. Click OK. To modify the groundwater depth under the ground surface, double-click on the groundwater level. The corresponding edit box appears, allowing you to modify the groundwater depth under the ground surface. To neglect the uplift pressure on the raft, groundwater level is chosen at anywhere under the raft basement. Type 30 in the groundwater depth under the ground surface edit box. Click OK. To modify the label of the pouring log, double-click on the label of the pouring log. The corresponding edit box appears, allowing you to modify the label. Type P1. Press Enter to consider the label. Now we have completed the definition of the soil properties and parameters. The screen should look like the following. Click Save and close the boring look window. To define the foundation properties, choose Foundation Properties from the Data tab. The following window appears with default foundation properties. For the given problem, it's required to define only the unit weight of the foundation. Any other data corresponding to foundation properties in the program menus aren't required. Therefore, the user can take these data from the default foundation properties. To enter the unit weight of the foundation, choose Unit Weight of the Foundation from Foundation Properties menu. The following dialog box appears with a default unit weight of 25. Type 0 in the unit weight edit box to neglect the foundation weight. Click OK. Save and close the foundation window. To define the loads, choose Loads from the Data tab. The following window appears. To enter the concentrated load, choose Point Loads from Graphical menu. When Point Loads command is chosen, the cursor is changed from an arrow to a crosshair. Then the load can be defined by clicking on the screen. When the screen is clicked, the following dialog box appears with the load value and coordinates. So, in the load edit box, type 8000 kilonewton. The X position will be 5.2 meter. The Y position is equal to 5.2 meter. Click OK. Save and close window. Now we have completed defining the data for the given problem. To analyze the problem, switch to Solver tab. ELPLA will activate the individual calculations list, which contains commands of all calculations. Commands of calculation depend on the used calculation method in the analysis. The items that are required to be calculated are assembling the load vector, determining flexibility coefficients of the soil, assembling the soil stiffness matrix, analysis of rigid pile groups, determining deformation, internal forces, and contact pressures. These calculation items can be carried out individually or in one time. To carry out all computations in one time, choose Computation of All. Once the analysis is completed, a check menu of the solution appears. This menu compares between the values of actions and reactions. Click OK. ELPLA can display and print a wide variety of results in graphics, diagrams, or tables through Results tab. To view the data and results of a problem that has already been defined and analyzed graphically, switch to Results tab. Results can be displayed in different ways, one of them as circular diagrams. Choose Circular Diagrams from Results menu. The following options box appears. Choose Settlements as symbol to be displayed. Click OK. Settlements are now displayed as circular diagrams for piles as shown in the figure. The function of Results tab list group is listing and printing data and results in tables. Data and results can be exported to other Windows applications like Word and Excel to prepare reports or add further information. Only one command of the list menu is explained here. In the same way, the user can carry out the remaining commands of the previous list. Commands of format and window menus, which are used to define the preferences of tables, such as page format and font, are discussed in detail in the user's guide of ELPLA. To list results in table, choose Display Tables of Results. The following option box appears. Select Pile Results as an example for the result to be listed in table. The following table appears. You can print this table of results or send it to Word to add further information.